get started. All right, so we're going to finish up section 6.1. That's why I put a B right there, because this is our second part. Part 2. Could have called it part 2, I guess. All right, let's do this. Let me grab a graph. You thought we were done with graphing, didn't you? Well, we just got started with graphing, so don't get too excited about not doing graphing anymore. All right, let's scooch it over to the side so I could write over here. All right. Let's see. Does blue show up? Can you see that? Yeah, that's pretty good. Okay. All right, so what we're going to do, if you look in the book, I don't have my book open, I just have my notes. But it's example 3. What page is that? Anybody got that open? What's example 3? What page? 250. Okay. So they have a graph. So let's try to graph it. 1, 2, 3, 0. Right there. 0, negative 2. 1, 2. This is 2, 1. Right there. And this is negative 1, 3. Negative 1, 1, 2, 3. All right. And what we're going to do is we're going to connect them all. And, well, you know what we're studying? Quadrilaterals. So it's going to be a quadrilateral. So they want to know what kind of quadrilateral is this going to be. Not just by looking at it and guessing. All right. You have to show, I know, but listen, but not just by looking at it and guessing. All right. We have to know exactly. It looks like a square, doesn't it? Yeah, and it is. I'll spoiler alert. Okay, it's a square. But we have to show why it's a square. So how in the world can we show that it's a square? What do you think? If I can show what about the sides? If I can show all 4 sides are equal to each other, does that alone make it a square though? No, because it could be a what? If I show all 4 equal sides, it could make it a rhombus. It could be a rhombus, okay? Because a rhombus has 4 equal sides. But, listen, a square is more specific than just 4 equal sides. It has to have all 4 sides equal, but it's got to have a little bit more. What else has to be true? It's got to have 4 right angles. How in the world, on a graph, can I show that I have right angles here? Sure you do.
The little squares.
Yeah, the little square, but how do I know that the little square indicates that it's a right angle? But how can I show that one line and another line make a right angle? They would be what? Give me a good geometry word. Perpendicular. They would be perpendicular. Okay? So do you remember, listen.
Negative reciprocal.
Yes, very good. So do you remember what it means for 2 lines to be perpendicular? Gavin said negative reciprocal. What about it? The slopes, right. Zion said the slopes of the 2 lines have to be negative reciprocals of each other. So what do we have to do then? We have to find the length of all 4 sides. So what are we going to use to find the length of all 4 sides? Distance formula, okay? What are we going to use? This is an easy one. What are we going to use to show that the lines are perpendicular? We're going to find the what of each of the lines? The slopes. We're going to find the slopes of the line, and then we're going to look at them and see if they're negative reciprocals. You with me? Here's another thing we didn't mention yesterday. Let's get my pen in the right direction here. Look at this segment right here, this side and this side. What do you think might be true about this side and this side? That's right. We didn't talk about that yesterday, but they will be, okay? The opposite sides of a rectangle will always be parallel, okay? Because it's a parallelogram as well. Okay, we talked about parallelograms yesterday, right? So it's also a parallelogram. A square is. So square is a bunch of things. It's quadrilateral. It's a parallelogram. It's a rhombus. It's a rectangle. Okay, it's not a kite. It's not a kite. It's basically all the things we talked about yesterday, except for a kite. Did we do trapezoid yesterday? Yeah, it's not a trapezoid. Okay, so it's not that. So it's not all of them, but it's a lot of them. So let's do the work. Okay. I'll go back to, come on, there we go. Oops, there we go. All right, so let's do this. Let's find, and they label these. I went back to white. Let's go back to the blue again. This one is R, just so we can refer to them. That's R. This one is S. This one is T. This one is U. All right? I tell you what, let's, just to make it easy, what's the ordered pair for R? Count over. 1, 2. Negative 3, 0. What's the ordered pair for S? No. Negative 1, 3, right? And then T? 2, 1. And then U? Running out of room here. 0, negative 2, right? 0, negative 2. All right, that helps out a little bit when we're doing the distance formula, so we don't have to refer back to this all the time, okay? So that makes it pretty easy. So what are we going to do first? Let's find the distance. How many distances are we going to have to find? 4 of them, right? So it's not that hard. Watch. This. So you're going to do this 4 times, all right? So hopefully you remember how to find the distance. We had a test on it recently, didn't we?
Yes.
All right. And so let's do it. So what do? Subtract the x's. So which one do you want to do? Let's do RS first, okay? I'll put the distance of RS. Do you see what I did right there? I don't think they do that in the book, but I do that. The distance of RS. So these two right here. So what are we going to do? Subtract the x's from each other. So it's negative 3 minus what? Negative 1. I should have made that bigger. And then what's this going to be? 0 minus 3. Let's do a little bit of this in our head. So add the opposite, or add a line, change sign. So it's going to be negative 2. What's negative 2 squared? 4 plus, what's that going to be? Squared 9. And so what is that? It's under a square root. What is it? So square root of 13. Okay. So remember, all I have to do is just show that all 4 sides are equal. So I got to do this 4 times. All right, 3 more times. I already done it once. So let's do the next one. So we've got RS. That is the square root of 13. All right. I know it's a weird looking number. It's okay. No big deal. What is the square root of 13 anyway? If you were to... Is it 3 point something? Actually, it is. I was thinking something else. Yeah, it's 3 point something. How do you know it's 3 point something? Because the square root of...
3.6, I said that.
Okay, listen. The square root of 9... I know you're excited about this, but calm your enthusiasm just a little bit. So watch. The square root of 13 is before the square root of 9 and the square root of 6, or it's in between, sorry, the square root of 9 and square root of 16, isn't it? Square root of 9 is 3, square root of 16 is 4, agreed? So square root of 13 has got to be somewhere between 3 and 4, all right? And Gavin guessed 3.6, and that's what it is. Now, it doesn't just stop at 3.6. It's an irrational number, which means it keeps on going forever and ever. So if you put it in your calculator, it'll go all the way to the end. And if you had a big computer that could go out multiple decimal places, it would keep going and going and going and going. It would never stop. Isn't that weird? All right, enough of that. Let's do this. Let's do ST next. ST, the distance of ST. These two right here. So we'll do this. We'll do this. All right, and now ST. So let's subtract them. Negative 1 minus 2, very good. And then what? 3 minus 1. See how easy it is after you do them? What's negative 1 minus 3? Squared, which is 9. 3 minus 1 is 2 squared, which is 4. How about that? So far, so good. So that's the square root of 13. And it should be, right? If this was going to be a square, that should be true. Let's do it 2 more times. Let's go kind of quick. Let's do TU.
If we do TU, we're not going to have to do RU. We're going to put all the sides are equal.
No, but what if it's not? What if, you know?
Well, that don't really be possible. TU.
Yeah, that's true, but we're going to do all 4. Okay. So let's do this again. All right, TU. So these two right here. So what are we going to subtract? 2 minus 0. So how easy it is? Just subtract the x's. Now subtract the y's. It's going to be 1 minus negative 2. All right. So what do we get? 2 minus 0 is 2. Squared is 4. This is going to be 3, right? Add a line, change sign. That's going to be 3. Squared is 9. And it's under a square root. So it's the square root of 13. So far, so good. Oops. What's the only one we haven't done yet? RU. So let's do that one. So listen to this. Distance of RU. So we do all this stuff. Aren't you glad you learned the distance formula? So RU, so what do we do? Negative 3 minus 0. And we probably could have done this in our head without writing everything down, but, whatever. What's the next one? 0 minus negative 2, right? Negative 3 minus 0 is negative 3 squared is 9. This is 2. Positive 2 squared is 4. Square root is the square root of 13. So at least we know it's a rhombus, don't we? Okay. Well, I said at least. At the very least, we know it's a rhombus because all four sides are equal. Agreed? Actually, the very least we know it's a quadrilateral, okay? But a little more specific than a quadrilateral, we know it's got to be at least a rhombus. But we can be more specific, though.
A rectangle can be a rhombus, though, right?
No.
Well, a rectangle could, because a rectangle could be a square,
A rhombus is 4 equal sides.
right? But
I thought a rectangle could be a square.
no, a rectangle could be a square if that rectangle has all four equal sides, right? A rectangle is not, listen, a kite is none of those things. A kite is not a rectangle, it's not a trapezoid, okay? It's, right, a kite is completely different. All right, let's do this. What do we got to do now? So we did distance, we found the length of all four sides, we found out that they're equal to each other. Now we got to find the slopes because we got to show that they are perpendicular, right? If they're perpendicular, it means they make a right angle. If they make a right angle, if all four of these make a right angle, then we can say it's a square, okay? So let's do it. So let's do the slope. Let's go in the same order. So let's do the slope of RS. Misses. All right. So what do we do? RS right here. What do we do on top?
No, 0 over 3.
0, not over 3.
Oh,
How about minus? 0 minus 3, okay? 0 minus 3. Subtract the y's from each other, put it on top. Then you subtract the x's from each other and put it on the bottom. So this is going to be negative 3 minus negative 1. So what is that? That's negative 3 over, what happens here? Plus, plus, negative 2. What is it? It's positive 3 over 2. So that's the slope of RS, okay? TU should be the same. Okay, we're going to go in the same order as we did these, okay? So let's do the slope of ST. And let's see what that is. Now, if they are perpendicular, what do you think? Let's think ahead a little bit. What do you think the slope of ST should be if RS was positive 3 over 2? It should be negative 2 over 3 if they're perpendicular. Let's see if they are, okay? I'm excited. Okay, here we go. So ST, we subtract the y's, so what do we get? 3 minus 1, right? 3 minus 1. And then subtract the x's, negative 1 minus 2. So what do we get? That's 3 minus 1 is 2 over negative 3. There you go. That is negative 2 over 3. So at least we know that we have a right angle there, don't we? Okay, so that's 1, all right? And you're right. Really, if you only showed 2 of them, that would be enough. But we're going to do all 4 of them just for fun. All right, so the slope of TU. So let's do TU. We got this down now. 1 minus negative 2. Let's just do that in our head. What's 1 minus negative 2? 1 minus negative? Minus a negative is plus, isn't it? So it would be positive 3. No. I guess I should have written it down. So let's do it. Let's write it down. 1 minus negative 2. Everybody see that? Okay. And then I'll do the x's. 2 minus 0. So do you see the minus negative is a plus? So it's a positive 3 over positive 2. And it should be, right? Because remember, this RS and TU should have the same slope. And they do. Both of them are 3 over 2. That's really enough to show that it's a rect or it's a square. But let's do one more. Just make sure. RU. All right, so RU are the two end ones right here. So let's see. 0 minus negative 2. Everybody see that? 0 minus negative 2. And then negative 3 minus 0. Negative 3 minus 0. That's positive 2 over negative 3. That's negative 2/3. Just like that is. And there we go. So we have right angles all over the place. That is. Well, it wasn't obvious. I mean, it kind of looked like it was, and we had an idea that it probably was a square, but now we actually proved it. We showed exactly that that is definitely a square. Okay? I don't know. I haven't even thought about that yet. All right, we good with that? Let's move on. So, it's definitely a square. Now we're going to do something a little bit different. Boom.
Does anybody got any extra loose leaf paper? Towel.
All right, what's this thing right here? Guys?
That looks like a kite. Look, that's a trap.
But I don't know anything. I don't know if these sides are parallel. I don't know if this is parallel to this. I don't know anything. So really, with all the information that's given right here, which is really no, it's a quadrilateral. It's just four sides. So we can't say anything. It might look a little bit like a kite, okay? But remember, these two have to be equal to each other. That definitely doesn't look equal to that, does it? Okay, same thing with this and this. It looks, maybe they're close, but that definitely looks longer than that. It's just a quadrilateral right now. So what we're going to do is we are going to do this. Everybody's listening? This is basically the rest of the lesson. So listen, please. We are going to find out the sum of all the interior angles of this quadrilateral. What does that mean? Sum means what? You're going to add up all the interior angles of the quadrilateral. So if I take this angle, add it to this, add it to this, add it to this, okay, I want to find out how many degrees that's going to all add up to be. Make sense? All right. Gavin already gave it away, but I'm going to show you why. Any guesses if you didn't hear him? Kite? I didn't even ask that. I just said it wasn't a kite. I just got done explaining why it's not a kite. Because we don't know that these two sides are equal. We don't know that these two sides are equal. So we can't say that it's a kite. I don't care. Listen, follow along. This is what I'm trying to figure out. The rest of today's lesson is doing this. It's trying to find out the sum of the interior angles of this figure. Okay, four-sided figure. Let's say it was a rectangle. Rectangle is a four-sided figure. A square is a four-sided figure. What if I added up? What if I added up all the angles on a square or a rectangle? That's easy. 90 plus 90 plus 90 plus 90, right? Is that four of them? Anyway, four of them. That would be 360. But is that true if it's not a rectangle? Well, let's figure it out. What I'm going to do is this. I'm going to draw a thing called a diagonal. I don't think they even say this in the book, but my other geometry books always said this. If I take any vertex, it doesn't matter. Let's just pick this one right here. And if I connect it to a non-consecutive vertex, what in the world does that mean? It means I can't go to the one right next to it. All right? So I only have one choice. It's to go to this one. What have I basically formed here? I formed two what? Two triangles. Now we already know the sum of all the angles in a triangle. We learned that earlier in the year. It's 180, okay? So watch. There's 180 degrees in this triangle, and there's what? 180 degrees in this triangle. If I add up all the degrees, what do I get? I get 360 degrees. Does that make sense? Okay? So they're going to ask you, what are the sums of the angles of a certain polygon? All right? We already know a triangle. All right? It's 180. We learned that earlier in the year. But now we got a four-sided figure, so the sum of all the angles, interior angles, of a quadrilateral is 360 degrees. You understand why we did that with the triangles? Because I know a triangle's got 180, and I know this triangle's got 180, so if I add up all the degrees, it's 360. So all four of these angles add up to be 360. Make sense? Yeah. All right. Let's do another one. Let's do this. I think I have a polygon doohick, and I can actually put the number of sides that I want in there. But the problem with this is, well, that's okay. We can still do it. Yeah, let's do it like this, just to stretch it, because I just want to make sure that... Guys are so excited today.
If you rounded the edge, then look at red.
All right, what if I wanted to, listen, what if I wanted to find out the sum of the angles of this figure? How many sides do we have? 1, 2, 3, 4, 5. Okay, there's 5 of them. Agreed? What if I wanted to find out all the angles of this? So, well, let's start at a vertex. It doesn't matter which vertex. Let's just start right here, okay? And draw, what did I call this thing? A diagonal, okay? So I just go to a vertex that's not right next to it, okay? So I don't go here and I don't go here. So where could I go? I could go to there, right? That's a diagonal. And then I could go one more though, couldn't I? I could go to here. Now, I want you to start looking for a pattern. Okay, I want you to look for a pattern. I had 4 sides. Let's write that down. I had 4 sides, and I had 2 triangles. Everybody see that? So I'm trying to establish a pattern. We'll do one more after the 5-sided one, the pentagon. All right, so I have 4 sides. I got 2 triangles. I have 5 sides. And how many triangles do I have? 1, 2, 3 triangles. So how do I find the sum of all these triangles? I add them up, or I could just do what? There's 3 triangles, so I could go 3 what? Times 180. Would you agree? Instead of going 180 plus 180 plus 180, I could just go 3 times 180. Wouldn't that be a lot easier? Yeah. All right. And that's what? 540? Yep. So the sum of all these angles. So that means if I add up this angle plus this one, plus this one, plus this one, plus this one, they're always going to add up to 540. It doesn't matter the shape of the pentagon. As long as you have 5 sides, it could be real weird looking, okay? As long as I got 5 sides and it's a polygon, every polygon, the angles, the inside angles, the interior angles are always going to add up to 540 degrees. We good with that? Okay. Let's do another one. Keep that red. Yeah, let's do 6. We'll go in order. And then, oops. Boom. Yes. What in the world? There we go. Yeah, you haven't been here at the beginning of class both days, and I've turned them back. And that yours is sitting right here. Here. Because I can't walk away from this. All right, here we go. Now let's let's stretch this out a little bit because I don't necessarily want this to look like, shh, guys, listen, please, come on. I'm running out of time and I don't need all the silliness. So what do we do? Start at a vertex. It doesn't matter what vertex, okay, but we're going to draw a what? Diagonal, thank you. So we don't go to here. Where do we go? We could go to there. How many triangles do you think we're going to get? Well, we got 6 sides. And then again, I start from that same vertex, and those are all my diagonals I can draw. Would you agree? Okay, there's 6 sides. There's 6 sides. So how many triangles do I have? 1, 2, 3, 4. I got 4 triangles. So when I have 6 sides, I have what? 4 triangles. You with me? How do I find the sum of the interior angles of all of this 6-sided figure, this hexagon? I go what? 4 times what? 180. And what's 4 times 180? 720. So that's the sum of all the angles. What does that mean? It means if I add up that angle, plus this one, plus this one, plus this one, and this one, if I add up all 6 of those angles, it's going to always add up to 720 degrees. All right? Any 6-sided figure, doesn't matter what shape, what the lengths of the lines, what the angles are, they're all going to add up to 720 degrees every time for a hexagon. Okay? Did you establish a pattern yet?
Yes.
4 sides, 2 triangles. 5 sides, 3 triangles. 6 sides, 4 triangles. What if I had 10 sides? How many triangles am I going to have? 8 sides, because it's always 2 less than the number of sides. I think I did. I did. Nope, I absolutely did. But I went through it super quick, and I said you're eventually going to get to it, and here we are. We eventually got to it. All right, so if I have 10 sides, I'm going to have what? 8 triangles. So it's always the number of sides, what? Minus 2. So if I had n number of sides, how many triangles would there be? There would be n minus 2 triangles. Okay? And I'm doing this for a reason, because we're going to have a little formula here. By the way, let's do the 10 sides thing. So how many, what's the sum of all the angles if I have 10 sides, a decagon? What would I do? What would my math be right here?
It would be 180 times 8.
That's right. I always do the 8 first, but it doesn't matter.
1080.
8 times, and that's 1080? Okay. I should have these memorized. I've taught this enough. Is it?
Yeah, it's
1440. Okay. Because I think the 1080 is if you had a octagon. So what is it, 1440? Okay. There you go. So if I have a 10-sided figure, listen, if I had a 10-sided figure, I want to add it up, all the angles inside of the 10-sided figure, I would get 1,440 degrees, 1,440 degrees. Everybody got it? Why? Because I would have 8 triangles. 8 times 180, right, is 1,440. You got it? Now, here's our little formula. All that to get to this. Now, I could have just started this lesson and say, okay, here's the formula to find the sum of the interior angles of any polygon. I could have done that. I could have just given it to you. We could have gone on our merry way and we would have been fine. All right, but I wanted you to see where these formulas come from. Sometimes I can do this, sometimes I can't. Sometimes it's too complicated. This one's not that complicated. All right, so if I wanted to find, and we got a formula. It's called the angle sum theorem, the convex polygon angle sum theorem. It's in the book. I don't know what page. It's a mouthful. The convex polygon, these are all convex polygons. Remember we talked about convex, concave? All right. These are all convex polygons, and it's the angle sum. We're finding out what the angles. Oh, this is Wednesday, isn't it? I only got 2 minutes. I thought I had 7 minutes. Okay, I can get this done pretty quick here. So here's the formula. We'll just call it the angle sum formula. Is that all right? Angle sum. I don't know if it's a theorem or formula. We'll call it a theorem, all right? What's it say in the book? Anybody got that?
What?
The angle sum theorem. It's in the book. It's written there somewhere. Yeah, but what is it a theorem though? Is it a theorem? Okay, good. That's all I wanted to know. So here's how you do it. The angle sum, okay, I'll just write this. The angle sum is equal to, what do you think? We take the number of, we go n minus 2, right? Because that's how many triangles we have, right? You always take how many triangles times what? 180, right? We went 8 triangles times 180. We went 4 triangles times 180. 3 triangles times 180, right? How many triangles do we have on a convex polygon? We have n minus 2 triangles, right? Take the number of sides, take 2 away from it, and that is your theorem right there. It's a nice little formula, and it's very useful. Let me do one more thing real quick. The bell's going to ring in a second, but just hang on a second, okay? I just want to show you one quick thing so we can finish this. And let me do, I'll just do 6 sides. It doesn't matter. Oh, there's one more thing. Man, if I had 5 more minutes. Okay, here we go. Everybody watch. Let me talk about this first. This is how many sides? 1, 2, 3, 4, 5, 6. So it's, let's do the math real quick. So it's, how many triangles would we have? So it's 6 minus 2, which is 4 times what? 180. Don't leave, don't leave. Don't leave. I asked you not to leave. I specifically said don't leave yet. Okay? So what would that be? 720? What if I asked you, listen to this. What if this was a regular polygon? What does that mean? All the sides are equal and all the angles are equal. Okay? So all the angles are exactly the same. Exactly right. Now watch. What if I asked you to find what each of those angles are? Well, they all add up to 720. How many angles do I have here? I have 6, so I divide by 6, and what's that? 120 degrees. So I know for a fact knowing that I have a regular hexagon, that each angle in a regular hexagon is 120 degrees. What if I ask, real quick, what if I ask for 8 sides, an octagon? That's a stop sign, right? It's a regular octagon. And if I wanted to go, I always tell people all this time, okay, get out of your car real quick. When you come to the stop sign, take your protractor, don't actually do this, okay? But actually, if you went up to a stop sign and you found out what that angle was, I could tell you exactly what it is. So if there's 8 sides, how many triangles? 6 times what? 180, and that would be what? 1080. Now, if there's 8 angles, how do you find out what each of those angles are? Divided by 8, and I think that's 135. So if you have a stop sign, each angle on a stop sign, no matter how big or how small, big or small the stop sign is, each angle is 135 degrees. There's one more thing. We'll do that super quick tomorrow. Okay, I just can't keep you anymore. All right. I want you to finish both those homeworks. Okay? You only have like a couple from that last one, and then do tonight's homework. I gave you the lesson plans yesterday, and I'll write it down here just in case somebody's watching this. So it's section 61B, page 253. And it's 19 to 34. So that's the homework for that lesson.